Hello friends, most welcome to my YouTube channel Maths by Samit Deshmukh. In the last video, we have proved first 9 properties of inverse trigonometric function. So properties are, again, remember that, are very important. Not only used in this chapter, but it can also be used in derivative, integration, differential equation, and can also be correlated with many another chapter. Now let us try to prove the next important property, that is property number 10. In this case, see, whatever may be the condition here is given to us related with what? X. It is nothing but domain of this inverse trigonometric function. Getting it? So already we have discussed about domain of inverse trigonometric function and range of inverse trigonometric function in last 2 videos. Okay, so now here we have to prove that sine inverse of x plus cos inverse of x is equals to pi by 2. So let us try to prove this result. So I am supposing that, so let y is equal to what? Sine inverse of x. This first inverse trigonometric function I am denoting by what? Y. So now y is the value of what? Sine inverse, means it lies in its range, and means it implies that what is the range of sine? It is in between what? Close interval minus pi by 2 to plus pi by 2, means y lies in between what? Minus pi by 2 to plus pi by 2, including minus pi by 2 and plus pi by 2. So now this can be written as, if we are taking sine on both sides, so on this side we will get sine y, and on this side if we are taking sine and sine inverse will get cancelled. What will the remaining term? X, according to our one property that sine of sine inverse of x will be equals to what? X. So therefore this sine y, can I write it as cos pi by 2 minus y? Yes, sine y can be written as what? Cos pi by 2 minus y. So therefore, this pi by 2 minus y, keep it as it is. On this side, x, on this side, we will get cos inverse of x, means simply we are taking cos inverse on both sides. So if we are taking cos inverse on this side, cos inverse and cos will get cancelled. On this side, what will get? Pi by 2 minus y, and if we are taking cos inverse on this side, we will get cos inverse of x. Now this pi by 2 minus y is the value of what? Cos inverse. If it is a value of cos inverse, means it should lie in its range set. Now we have to check that this value lies in the range of cos inverse or not. And what is the range set of cos inverse? 0 to pi. Let us check whether this value lies in this interval or not. So now here, what is the given according to this condition? So since y is what? Greater than or equals to minus pi by 2 and less than or equals to what? Pi by 2. So just we are representing close interval in this symbolic form also. So this is the another representation of close interval. Now here we will require what? Minus y. We are just trying to arrange this term pi by 2 minus y. So first try to exist minus y. To exist minus y, here we have to multiply to all the terms by minus. So if I am multiplying here by minus, it will become plus pi by 2. And here inequality will get changed, so here we will get minus y, here we will get inequality will get changed, and here we will get minus pi by 2. Just simply we are multiplying by minus. At that time we know that inequality will becomes reverse, means less than or equals to will become what? Greater than or equals to. Now to get this result, we have to add what? Pi by 2 in this term. So we are adding pi by 2 in every term. Pi by 2 plus pi by 2 will become pi. If I am adding pi by 2 here, so here we will get pi by 2 minus y, and if I am adding pi by 2 in the last term, minus pi by 2 plus pi by 2 will become 0, which implies that this pi by 2 minus y belongs to which interval? 0 to pi. So we have proved that this value lies in the range of what? Cos inverse. So that's why we are able to consider this as what? Principal value. So therefore, now this pi by 2, keep it as it is. So this minus y on this side will become plus y. Y plus cos inverse of x. So this implies that, so y means what? Sine inverse of x. So on this side pi by 2, keep it as it is. Sine inverse of x plus cos inverse of x, keep it as it is. And this is the result which we have to prove. Just write down this on the left hand side, means sine inverse of x plus cos inverse of x, and what is its value? Equal to pi by 2. In this way, we have proved our first property, that is sine inverse of x plus cos inverse of x is equal to what? Pi by 2. Same method we are applying in the next property, means in 11th property. In this, we already know that tan inverse and cot inverse takes the values on what? Whole real number line. So that's why here we are saying that R is equal, x belongs to what? R. Now we have to prove that tan inverse of x plus cot inverse of x is equals to pi by 2. So here we are supposing that let tan inverse of x is equals to what? Y. If y is the value of tan inverse of x according to our supposition, means it implies that y belongs to which interval? It belongs to range of tan inverse. And what is range of tan inverse? Open interval minus pi by 2 to plus pi by 2. So therefore, taking tan on both sides, on this side if we are taking tan and tan inverse will get cancelled, remaining term is x. On this side we will get tan inverse of y. So therefore, we have taken tan on both sides. So on this side we will get tan y. So x, keep it as it is. Tan y according to allied angle formulas, can I write it as cot pi by 2 minus y? Yes, it can be written as what? Cot pi by 2 minus y is equal to tan y. So taking cot inverse on both sides. So on this side we will get cot inverse of x, and if we are taking cot inverse on this side, cot and cot inverse will get cancelled according to property of inverse trigonometric function. And what is remaining term? Pi by 2 minus y. Now pi by 2 minus y is the value of what? Cot inverse. So we have to prove that it belongs to the range of cot inverse. And what is the range of cot inverse? 0 to what? Pi. So let us check whether this value belongs to our range or not. So since what is the given, according to given condition, according to our supposition, y belongs to which interval? Minus pi by 2 to plus pi by 2. Now here to exist minus y, we are multiplying to all the terms by minus. So here we will get plus pi by 2. Since we are multiplying by minus, so less than will become greater than. Here we will get minus y. Again here we will get greater than, and here we will get minus pi by 2. Just simply we are multiplying by minus. Now we are adding pi by 2. If we are adding pi by 2, here we will get pi. Here we will get pi by 2 minus y, and here if we are adding pi by 2, we will get 0. So here we can observe that this pi by 2 minus y belongs to which interval? Belongs to 0 to pi. And since it belongs to range of what? Cot inverse. So we are able to consider it as what? Principal value of cot inverse. So therefore, this minus y on this side will become plus y. Keep this cot inverse of x as it is. On this side remaining term is what? Pi by 2. Now replace this y by its value. What is the value of y? Tan inverse of x plus cot inverse of x is equals to what? Pi by 2. And this is the result which we have to prove here. So in this way we have proved 11th property also. Now let us try to prove the 12th property. In this case we have to show that value of cosec inverse of x plus sec inverse of x is equals to what? Pi by 2. So here we are supposing that let cosec inverse of x is equals to what? Y. So which implies that y belongs to minus pi by 2 to plus pi by 2, difference 0. So because we know that if y is the value of cosec inverse, means it should belongs to range of cosec inverse. So therefore it can be written as, if we are taking cosec on both sides, so here cosec and cosec inverse will get cancelled, remaining term is x, and on this side we will get cosec y. So according to allied angle formulas, cosec y can be written as what? Cot pi by 2 minus y. Now if we are taking cot inverse on both sides, so on this side we will get cot inverse of x, and on this side cot and cot inverse will get cancelled. What is remaining term? Pi by 2 minus y. Now pi by 2 minus y is the value of what? Cot inverse. To consider it as principal value, we have to prove that it belongs to domain of cot inverse, means in between what? 0 to pi. So let us consider here a given condition. Since y is less than or greater than or equals to minus pi by 2 and less than or equals to what? Plus pi by 2, and y is not equals to 0. Using this condition, let us try to show that this value belongs to what? This value belongs to range of cot inverse, means in between 0 to what? Pi. So this can be written as, to get minus y, we are multiplying to all the terms by minus. So multiply by minus, here we'll get plus pi by 2, inequality will get change. Here also inequality will get change, and if we are multiplying by minus, so here we will get what? Minus pi by 2. Now we are adding pi by 2 to all the terms. If we are adding pi by 2 to all the terms, here what we will get? Pi. Here we will get greater than. Here we will get pi by 2 minus y. And if we are adding pi by 2 here, minus pi by 2 plus pi by 2 will become 0. So here we will get 0. So this implies that y pi by 2 minus y belongs to which interval? 0 to pi. This belongs to 0 to pi, and since this belongs to 0 to pi, means it belongs to what? Range of cot inverse, and that's why we are able to consider it as what? Principal value. So this implies that minus y on this side will become plus y, plus cot inverse of x, keep it as it is. On this side remaining term is what? Pi by 2. So now I am replacing y by its value. What is the value of y? Cosec inverse of x. So what we'll get here? Cosec inverse of x plus cot inverse of x is equals to what? Pi by 2. And this completes the proof of this 12th property. Now we are going to prove the 13th very important property. In this case, we have to show that value of tan inverse of x plus tan inverse of y is equal to tan inverse of x plus y upon 1 minus xy. Now this property is satisfying when x is greater than 0 means x is positive, y is greater than 0 means y is positive, and value of xy is less than what? 1. So similar type of 3 properties are there related with what? Tan inverse of x plus tan inverse of y. This result we are getting if xy satisfies this condition. Again, in next property here, less than is replaced by greater than, and in the third property it will be replaced by what? Equal to. Xy is equal to 1. Means we are getting 3 important property related with what? Tan inverse of x plus tan inverse of y. Well, as far as this property is concerned, we have to show that value of tan inverse of x plus tan inverse of y is equal to tan inverse of x plus y upon 1 minus xy. Let us try to prove this result. Now let us denote first term say by theta. So let theta is equals to tan inverse of x, and denote this term say by phi, and phi is equals to tan inverse of y. Just we are denoting first term by theta and the second term by what? Phi. So if we are taking tan on both sides, so here we will get tan theta is equal to x, and here we will get, taking tan on both sides, here we will get tan phi is equals to y, because if we are taking tan on both, on this side tan and tan inverse will get cancelled according to our one property. Tan of tan inverse of y is equals to what? Y. Now we are using given condition. What is the value of x? Tan theta. What is the value of y? Tan phi. Now it is given to us that x is greater than 0. So since x is greater than 0, and even it is given to us that y is also greater than 0, so it implies that if x is greater than 0 means x is positive. If x is positive means value of tan theta also positive, and if tan theta is positive means, can I say that it lies in the first quadrant? If it lies in the first quadrant, if tan theta is positive means theta lies in the first quadrant. First quadrant means what? In between 0 to pi by 2. In the same way, y is positive means tan phi is positive. Tan phi is positive only if this phi lies in first quadrant, means value of phi is greater than 0 and less than what? Pi by 2. Okay, so this implies that if we are taking addition of these two equations, what is the addition? 0 plus 0 will be 0, keep greater than as it is, theta plus phi will be equals to theta plus phi, and here pi by 2 plus pi by 2 will be equals to pi. Let us denote it by equation number first. Now here what result we have got here? Theta plus phi. Why we are finding value of theta plus phi? Because theta is tan inverse of x and phi is what? Tan inverse of y. Well, now we have shown that this value lies in between 0 to pi. 0 to pi means how many quadrant? 2 quadrant, first and second. Getting it? Now we have one formula which is called as compound angle formula, or it is also called as what? Addition subtraction formula. So write down that formula. We know that our example is related with what? Tan inverse. So that's why we are using the formula of tan theta plus phi can be written as tan theta plus tan phi divided by 1 minus tan theta into tan phi. These formulas we have proved in class 11, that tan a plus b is equal to tan a plus tan b upon 1 minus tan a into tan b, isn't it? A is replaced by theta and b is replaced by what? Phi here. So which is equals to, now observe here, tan theta means what? Tan theta means x and tan phi means what? Y. So replace tan theta by x and this tan phi by y. On this side also 1 keep it as it is minus tan theta can be replaced by x, tan phi can be replaced by y, and this is the value of what? Tan theta plus phi. Okay, so now simplifying it, if you are taking tan inverse on both sides, on this side tan inverse and tan will get cancelled, remaining term is what? Theta plus phi. So therefore here we will get theta plus phi, and take tan inverse on right hand side. So on right hand side we will get tan inverse of x plus y upon 1 minus xy. Now here we can observe that theta plus phi is the value of what? Tan inverse. If it is the value of tan inverse, means we have to prove that it lies in the range of what? Tan inverse. And what is the range of tan inverse? Minus pi by 2 to plus pi by 2. As this tan theta plus phi lies in what? 0 to pi. 0 to pi means which quadrant? First quadrant. 0 to pi means first and what? Second quadrant. And minus pi by 2 to plus pi by 2. Here 0 to pi by 2 and 0 to minus pi by 2. Minus by minus, because if you are taking clockwise direction, at that time that angle can be considered as what? Negative angle. Means minus pi by 2 to plus pi by 2 means which two quadrant? First and fourth. We know that principal value of tan inverse lies in this interval, but as it stands this value lies in what? First and second quadrant. फर्स्ट चलेगा हमें, लेकिन सेकंड में नहीं जा सकते हम, बिकॉज फर्स्ट क्वाड्रेंट बिलोंग्स टू व्हाट? माइनस पाई बाय 2 to plus pi by 2. Now let us simplify it and try to show that it belongs, means this value, this is the value of what? Tan inverse. So it belongs in between what? Minus pi by 2 to plus pi by 2. Well, let us try to prove it. Now it is given to us that, what is given condition? X is greater than 0 and y is greater than 0. If x is greater than 0 and y is greater than 0, means what is your conclusion? X and y are positive number, and addition of two positive number. Why we are finding addition? Because in numerator addition is there. So if these two numbers are positive number, means can I say that their addition is also positive? Positive means it will be greater than what? 0. And what is the second given condition? Xy is less than 1. Xy is less than 1. From this we are finding value of denominator, means we have to check whether the denominator is positive or negative. So now we are finding difference of 1 and xy. We have to check that this difference is positive or negative. Now observe that xy is greater or 1 is greater? 1 is greater. And from this greater number we are subtracting smaller number. 1 is greater than what? Xy. And from the greater number, if we are subtracting smaller number, means definitely the result will be positive. So this value is also positive. And if you will observe this, x plus y is numerator, 1 minus xy is denominator. So numerator is also positive and this denominator is also positive. If both numbers are positive, then their division is also what? Positive. So this implies that x plus y upon 1 minus xy is what? Positive. Now x plus y divided by 1 minus xy is the value of, this is the value of what? Tan. And if the value of tan is positive, means definitely this angle lies in what? First quadrant. So this implies that theta plus phi lies in what? First quadrant, means in between what? 0 to pi by 2. Here what we have got? फर्स्ट एंड सेकेंड क्वाड्रेंट। अब हमने क्या प्रूफ कर दिया, इसमें से सेकेंड क्वाड्रेंट डिलीट हो गया यूजिंग गिवन कंडीशन। एंड 0 to pi by 2, 0 to pi by 2 is the part of what? Minus pi by 2 to plus pi by 2. So this implies that theta plus phi belongs to which interval? 0 to pi by 2, which is the subset of what? Minus pi by 2 to plus pi by 2, isn't it? So that's why we are able to consider this value as an what? Principal value of this what? Inverse trigonometric function tan inverse. We are able to consider this as a principal value of tan inverse. So let us denote it by next equation number 2. So therefore from equation 2, what we are getting? Theta plus phi is equals to tan inverse of x plus y upon 1 minus xy. So theta can be replaced by its value tan inverse of x, and phi can be replaced by its value tan inverse of y. On this side, tan inverse of x plus y upon 1 minus xy, keep it as it is, and this is the result which we have to prove here. अभी आप सोचेंगे कि यहीं पे अगर हमने थीटा और फाई की वैल्यू सब्स्टिट्यूट कर दी, what is theta? Tan inverse of x, and phi is what? Tan inverse of y. We will get our required result. But remember that this is the value of what? Tan inverse. If it is the value of tan inverse, we have to prove that it belongs to what? Range of tan inverse. Then and then only you will get marks here, getting it? So that this whole process we have used to prove that this value belongs to what? Range of tan inverse, and that's why we are able to consider it as what? Principal value. In this way we have proved a very important property. This property can be asked in the examination for 4 marks. So in this property, what we have proved? Tan inverse of x plus tan inverse of y is equal to tan inverse of x plus y upon 1 minus xy. This condition is satisfying if x and y are positive and xy is less than 1. Similar type of property is there. Property number now 14. See, in this property number 14th, we have to show that value of tan inverse of x plus tan inverse of y is equal to pi plus tan inverse of x plus y upon 1 minus xy. Last case में क्या था? यहाँ पे xy is less than 1. Now here what is there? xy is greater than 1. If xy is greater than 1, at that time on the right hand side, pi is added. Last property में यहाँ पे pi नहीं था. So when this pi is included on the right hand side or added on the right hand side, if xy is what? Greater than 1. So well, now let us try to prove this property. Same method we are applying which we have seen in the last property. So I am denoting this first value say by theta. Let theta is equals to tan inverse of x, and second value I am denoting by phi. Phi is equal to tan inverse of y. Now if you are taking tan on both sides, so on this side we will get tan theta and on this side we will get x, because on this side tan of tan inverse of x will be equals to x. Now if you are taking tan on both sides, here we will get tan phi, and here tan and tan inverse will get cancelled. What we will get here? Y. Okay, now here it is given to us that x and y both are what? Positive. So since x is greater than 0, x is what? Greater than 0, and y is also greater than 0, implies that now x is greater than 0 means tan theta is greater than 0, and when the value of tan theta is greater than 0 means positive if this theta lies in first quadrant. First quadrant means it is in between 0 to what? Pi by 2. In the same way, y is positive means tan phi is positive. Tan phi is positive means this phi also lies in first quadrant, means it lies in between 0 to what? Pi by 2. So this implies that if you are adding these two equations, 0 plus 0 is 0. Here theta plus phi is theta plus phi, and here pi by 2 plus pi by 2 will be equals to pi. Let us denote it by equation number first. Okay. Now again use same method. We know one formula. We know that what is allied angle, what is compound angle formula? Tan theta plus phi can be written as tan theta plus tan phi upon 1 minus tan theta into tan phi. Now I am replacing tan theta by its value. What is the value of tan theta? X. Plus here replace it by what? Y, because tan phi is equal to y. In the denominator also replace tan theta by x and tan phi by y. This is the value of what? Tan theta plus phi. So denote it by equation number 2. Now we can observe that here this x plus y upon 1 minus xy is the value of what? Tan theta plus phi. Tan on this side will become what? Tan inverse. Means here theta plus phi is the value of what? Tan inverse. Getting it? If we are taking tan inverse on both sides, here tan will get cancelled. Remaining term is theta plus phi. And theta plus phi will become the value of what? Tan inverse of x plus y upon 1 minus xy. Now if it is the value of tan inverse, means we have to prove that it belongs to what? It belongs to range of what? Tan inverse. So here theta plus phi, let us check whether it belongs to that range or does not belongs to that range using the given condition. So now what is the given condition here? Since x and y, x is also positive and y is also positive. So since x is greater than 0 and y is also greater than 0. If both the values are greater than 0, it implies that their addition. Why we are finding addition? Because in numerator addition is there. Here it is given to us that x and y are positive number. That's why we are saying that their addition is also what? Positive. Now we will observe the denominator. To find out value of denominator, we are using second condition. xy is greater than xy is greater than what? 1. So this implies that 1 minus xy will be, we have to check that this value is positive or negative. Which number is greater? Xy is greater and 1 is what? Smaller. So from the smaller number, if you are subtracting greater number, from smaller number, say from 2, if you are subtracting 5, means from smaller number if you are subtracting greater number, means definitely the answer will be negative. Means here we can say that this value is negative. Now numerator is positive, denominator is what? Negative. So it implies that x plus y upon 1 minus xy is what? Less than 0, because x plus y is positive, means numerator is positive, and 1 minus xy is what? Denominator. So numerator is positive, denominator is negative, then definitely the division of positive and negative number will be negative number. If this is negative number, now already this theta plus phi lies in between what? 0 to pi. 0 to pi means which two quadrant? It lies in either in first quadrant or in what? Second quadrant. लेकिन हमारा tan इनवर्स का प्रिंसिपल वैल्यू कौन से इंटरवल में लाई होता है? -π/2 to what? +π/2. Our principal value lies in this interval. As a stand, value of tan is what? This value is negative. This value is negative means definitely it does not lies in first quadrant, means definitely it lies in what? Fourth quadrant. So हमें proof करके बताना है that this value belongs to what? Fourth quadrant. Okay. So now let us try to show that it belongs to what? Fourth quadrant. But first we are using this condition that theta belongs to what? 0 to pi, यानी first and second quadrant. लेकिन अभी हमने क्या प्रूफ करके बताया कि ये जो tan की वैल्यू है ये निगेटिव है, and value of tan is negative means definitely it does not lies in what? First quadrant. First quadrant तो delete हो गया because we have proved that this value is negative, and in first quadrant value of tan is what? Positive. तो बचा कौन सा quadrant? Second quadrant. Second quadrant में tan की वैल्यू क्या है? Negative है. Means that's why we are saying that here that theta plus phi lies in between pi/2 to what? Pi. Okay. पहले क्या प्रूफ किया था हमने? It lies in first or in second quadrant. लेकिन अब first quadrant क्यों delete हो गया? Because we have proved that value of tan theta is what? negative, this value is negative, which is nothing but value of tan theta. तो इसका मतलब this theta means this angle theta plus phi does not lies in which quadrant? First quadrant. तो first quadrant इसमें से निकाल दो तो बचेगा कौन सा quadrant? Second quadrant. But second quadrant does not belongs to what? Range of tan inverse. To prove that it belongs to range of tan inverse, we are doing some adjustment here. So try to understand that this adjustment. Just simply we are subtracting pi from each term. If I am subtracting pi here, so here pi by 2 minus pi. Again, here also we are subtracting what? Pi, and here also we are subtracting what? Pi. Let us see what we'll get. Pi by 2 minus pi will be minus pi by 2. Here theta plus phi, keep it as it is, minus pi also as it is. Here difference of these two terms will be equals to 0. Now what we have proved, this number lies in between what? 0 to minus pi by 2. 0 to minus pi by 2 means it lies in which quadrant? Fourth quadrant. And fourth quadrant belongs to what? Minus pi by 2 to plus pi by 2. So we are able to consider it as what? Principal value of tan inverse. So when we are able to consider it as a principal value, so if we are able to adjust this term in this expression, so we are considering expression number 2. So from equation 2, what is the equation 2? Tan theta plus phi is equals to what? Tan theta is equals to, better way consider this equation, is equal to x plus y upon 1 minus xy, isn't it? So therefore tan, now try to understand here. So here pi, can I write it in this form? Pi minus theta plus phi. On this side, x plus y upon 1 minus xy, keep it as it is. Now try to understand it very carefully. Can I write tan theta plus phi in this form? So see, what is the value of this expression? Tan pi minus theta, consider this whole term as theta. What is the formula? Tan pi minus theta is equal to minus tan theta, लेकिन यहाँ पे माइनस नहीं है तो हम क्या करेंगे, यहाँ पे माइनस दे देंगे. अभी अगर इसे सिंप्लीफाई किया तो ये रिजल्ट आता है या नहीं आता है, ये देख लेते हैं. सो tan pi minus theta will be equals to minus tan theta. Minus and this minus will become what? Plus. Yes, after simplifying we will get this result. So this expression can be written in this form. Now again we are simplifying it. Minus tan, keep it as it is. Now here I am taking minus common. If we are taking minus common, so what we will get here? This negative term will become positive. And this positive term will become what? Negative. Just simply we have taken what? Minus common here. This negative term will become positive, positive will become what? Negative. On this side, keep x plus y upon 1 minus xy as it is. Okay. Now this expression is in the form of tan minus theta. Consider this whole term as theta. And what is the value of tan minus theta? It's minus tan theta. Minus and this minus will become what? Plus. Means what we will get after simplifying it? Tan theta. Theta is what here? Theta plus phi minus pi. On this side, x plus y upon 1 minus xy, keep it as it is. Again here this expression is in the form of tan minus theta. Minus and this minus will become what? Plus, isn't it? So therefore theta plus phi minus pi is equals to, just simply we are taking tan inverse on both sides. If we are taking tan inverse of left hand side, tan inverse and tan will get cancelled. This is the remaining term. So take tan inverse of right hand side also, tan inverse of x plus y upon 1 minus xy. Okay. Now this is the value of what? Tan inverse. Means it should belongs to what? Range. And what is the range? Minus pi by 2 to plus pi by 2. Already we have proved that this value lies in between what? 0 to minus pi by 2. And yes, 0 to minus pi by 2 is the part of this whole range set, minus pi by 2 to plus pi by 2. So we are able to consider this as what? Principal value. Why? Because already we have proved that it belongs to the range of tan inverse. So this implies that theta plus phi is equals to minus pi on this side will become plus pi plus tan inverse of x plus y upon 1 minus xy. Keep it as it is. Lastly, we are substituting the value of theta and phi. What is the value of theta? Theta is tan inverse of x and phi is what? Tan inverse of y. So replace this theta by tan inverse of x, phi by tan inverse of y, and on this side pi plus tan inverse of x plus y upon 1 minus xy. Keep it as it is and check whether is it our required result which we have to prove. Yes, in this way we have shown that tan inverse of x plus tan inverse of y is equal to pi plus tan inverse of x plus y upon 1 minus xy. To apply these properties in both properties, means in 13th and 14th, our left hand side is same. Minor change is on what? Right hand side. In the 13th property, pi is not there, and in 14th property, pi is there. Pi plus tan inverse of x plus y upon 1 minus xy. So remember this difference. When we are applying 13th property, if product of xy is less than 1. When we are applying 14th property, if x into y is greater than 1. This condition we have to observe while solving the example. That's why while applying this property related with what? Tan inverse of x plus tan inverse of y, you have to check that product of xy is either greater than 1 or less than 1. If it is less than 1, apply last property. If it is greater than 1, then apply this property. Okay. Now we are going to prove another property if xy is equals to 1. If xy is equal to 1, then we will see how to find out the value of tan inverse of x plus tan inverse of y. See in the property number 15, here only the change in the condition is what? Xy is equals to what? 1. If x into y is equals to 1, at that time we have to prove that value of tan inverse of x plus tan inverse of y is equals to what? Pi by 2. The method which you have seen in last two properties, exactly same method we are applying here. Denote first term by theta, second term by phi. So therefore from this we will get x is equal to tan theta, from this we will get y is equal to tan phi. It is given to us that x and y are positive, means here tan theta is positive, means theta belongs in first quadrant. Here also tan phi is positive, that's why phi also belongs to what? First quadrant, means it between 0 to pi by 2. Adding these two equations, we will get this equation number first. This steps we are seen in last two properties also. Again we are applying same formula. Tan inverse of theta plus phi can be written as tan theta plus tan phi upon 1 minus tan theta into tan phi. Replace tan theta by x and tan phi by y. We will get this expression. Now we are using given condition to check whether this value is positive, negative, 0 or does not exist. What is the numerator? X plus y. Now first check that x plus y is positive or not. What is given condition here? X is greater than 0. So since x is greater than 0 and even y is also greater than 0, means it implies that their sum of two positive number is what? Positive number. Now let us try to find out value of this denominator. Denominator means 1 minus xy, and to find out value of 1 minus xy we are using second condition, and it is given to us that xy is equals to 1, which implies that 1 minus xy. These two numbers are equal. These two numbers are equal means their difference will be equals to what? 0. If the difference is equals to 0, means we can say that therefore x plus y upon 1 minus xy. So means one number is what? Positive, and this number is positive means numerator is positive, and this number denominator is what? 0. So any number divided by 0 is what? Undefined value. Undefined value we are denoting by what? Infinity. Means what result we have got here? Tan theta plus phi will be equals to what? Infinity. So can I write this expression as tan theta plus phi is equals to, now value of this tan is infinity, means this we are finding value of this angle which satisfies this condition. Already we have proved that theta plus phi lies in between what? 0 to pi. Is there is any angle between 0 to pi where the value of tan is infinity? Yes, we know that value of tan is infinity at what? Pi by 2. That's why we are able to replace tan infinity by what? Tan pi by 2, and yes, this value belongs to what? 0 to pi. It lies in between 0 to pi. So by comparing both sides, we can say that theta plus phi is equal to what? Pi by 2, isn't it? So which belongs to, so this implies that theta is how much? Tan inverse of x, and phi is how much? Tan inverse of y. Keep this side as it is, pi by 2. In this way, we have got our required result that tan inverse of x plus tan inverse of y is equal to pi by 2. So in this way, we have seen three properties related with what? Tan inverse of x plus tan inverse of y. In the first property, xy is less than 1. In the second property, xy is greater than 1. And in the third property, xy is equals to. Now see the property number 16. In this case, x and y is greater than 0, which we have seen in last three properties also. So using this, we have to show that value of tan inverse of x minus tan inverse of y is equal to tan inverse of x minus y upon 1 plus xy. So we are using again same method, denote this first term by theta, second term by phi. So therefore, taking tan on both sides, we will get this result. Since x and y are positive, means theta lies in first quadrant and phi also lies in what? First quadrant. Now focus on our required result. What is required result? Tan inverse of x minus tan inverse of y. Tan inverse of x means what? Theta. Tan inverse of y means what? Phi. Now we are finding, or we are trying to exist the term of what? Theta minus phi. So here theta is positive, but here we will require what? Minus phi. To get minus phi, I am multiplying to all the terms by minus. We know that whenever we are multiplying by minus, inequality will get changed. Means less than will become what? Greater than. So here we will get, if we are multiplying by minus, here we will get 0. Here we will get minus phi. Again less than will become greater than. Here we will get minus pi by 2. Now can I write this expression as minus pi by 2 is what? Less than what? Minus phi. So minus phi, keep it as it is, and minus pi by 2 is less than what? Minus phi, and minus phi is less than 0, is less than what? 0. Same expression we have written here. This arrangement we have changed. So keep this equation as it is. 0 is less than theta, and theta is less than what? Pi by 2. Now if we are taking addition of these two equations, let us see what we will get. So 0 minus pi by 2 will be minus pi by 2. Again here theta minus phi will be theta minus phi, and pi by 2 plus 0 will be equals to what? Pi by 2. Pi by 2 plus 0 will be equals to pi by 2. Now we have proved that this value lies in what? Minus pi by 2 to plus pi by 2. And yes, what is the range of tan inverse? Range of tan inverse is also what? Minus pi by 2 to plus pi by 2. And here already we have got this result that this value lies in the range of tan inverse. Now we will use one given condition. So we know that what is compound angle formula? What is that formula? Tan theta minus phi, because our example is related with what? Minus. That's why we are applying this formula. Tan theta minus phi can be written as tan theta minus tan phi upon 1 plus tan theta into tan phi. So which is equal to, replace tan theta by x, tan phi by y. In the denominator 1 plus, again tan theta is x, tan phi is what? Y. On this side tan theta minus phi, keep it as it is. Now this tan, on taking tan inverse on both sides, here we will get theta minus phi, and on this side we will get tan inverse of x minus y upon 1 plus xy. Just simply we have taken what? Tan inverse on both sides. So on this side tan inverse and tan will get cancelled, remaining term is theta minus phi, and on this side we will get tan inverse of x minus y upon 1 plus xy. Now this is the value of what? Tan inverse, but already we have proved that this value of tan inverse belongs in what? Range. So that's why we are able to consider it as what? Principal value. Already we have proved that this value belongs to what? Range of tan inverse. So this implies that, replace theta by what? Tan inverse of x, and phi by what? Tan inverse of y is equals to tan inverse of x minus y upon 1 plus xy. So in this way we have proved the last important property. See, again many properties are there in case of inverse trigonometric function, but as per as our syllabus is concerned, these properties are given for proof. So in this way we have completed a theoretical part of inverse trigonometric function. In the next video we will solve the examples, means we will start the next exercise related with what? Inverse trigonometric function.